Good afternoon, students. Welcome back to the next lecture on database management system. So today we'll start a small discussion on database design. So we already aware that a database is a collection of raw data, and we'll arrange them in different tables or different formats. So how to design a database whenever it is needed. So what is the primary role of a database? First of all, so the database should have right. Very keen consistency, very important parameters we have to consider or we have to keep in our mind while you are designing a database is first point is its consistency. Data consistency is a primary factor while you are designing a database, right? And next, its integrity also you have to maintain. So what is mean by consistency and integrity? So for example, if I want to prepare a database for the student database, for example, if I want to prepare a student database, right, in the student database, right, I want to avoid, right, multiple roll numbers. So I repeat, so the roll number should be unique. So that is one constraint. And I want to maintain all the students who belongs to a particular department. For example, if I consider CSE or if I consider ECE, they should be categorized or they should be classified into a one group. So these are the different constraints. So these constraints we have to keep in mind while you are designing a database. So to design these database, right, various steps we have to consider. So in the due course, we'll see all these steps. So today we'll just talk about what are the steps and a little bit intro about each step. Then we'll talk about ER diagrams, entity relationship diagrams. So first key point while you are designing a database is data consistency and data integrity. And next we have to take care of redundancy also. Very low redundancy we have to maintain. So redundancy means repetition of data. So if you take a database table like this, in this table, right, so for example, roll number 1 we have 2, and this roll number 1 Mrs. Sam, roll number 2 is Mrs. Sachin, and roll number 3 is again Sam. So in this, the Sam and Sam was repeated 2 times. So this Sam and Sam are repeated 2 times. This is a redundancy actually. So we'll try to overcome this type of redundancies. Okay. Actually, this is not actually a redundancy. I'll show you a better example for redundancy now. For example, let me take a table, serial number here, and then name here. Okay. And the section here. Okay. So serial number 1, serial number 4, serial number 8, serial number 124. For example, if I take, so serial number 1 is Sachin, and serial number 4 is Mr. Raju. Sachin section, he belongs to A section, and Mr. Raju belongs to A section. And serial number 8 is Mr. Suresh, and he belongs to B section. And serial number 124, he is Mr. Somu, right? He is again from A section. So if you observe this table, in the section column, this A was repeated for multiple times. So in the 4 entries, there are 4 entries we have. So in the 4 entry, the section A was repeated for 3 times. So what I want to say is this A, if I mention them as somehow differently, so if I try to avoid this section here, so that the redundancy, the repetition part can be right eliminated, so that I can save the storage elements, searching elements and all. So when the storage reduces, searching will become fast, right? So these things we have to keep in our mind while we are taking care of the design. Next, this 3 parameters help us to search the data very faster. So for that, we also take care of, right, adding some indexing. So file indexing concepts we'll see here. So indexing. So this indexing also will take care. So what is this indexing and all, we'll see in the coming sessions. So the design should also allow us to use the indexing concepts. And next, it has to take care of the security constraints, right, whatever you have. So the data integrity is most important parameter as we discussed. So it has to take care of the security parameters also. And the last one, right, so it has to provide a fundamental storage provision means whatever data we are storing, whatever data we are writing in a database, it has to store in the bits format, right? So this should be in the form of bits, and that bits should be stored in the unique atomic structure, right? What is atomic structure we'll see in today's session, right, in some time, right? So that is the critical points or very common points we need to consider in your mind when you are designing a database. Okay, so normally designing database means you have to follow various steps. So these are the various steps we have to follow, right? Very first step is requirement analysis. So for example, if you want to prepare a database for student data, right? So what are the right entities, or what are the parameters, what are the fields, and what are the columns, etc. You need to consider, right? You need to gather. So for example, to prepare the student database of a college, right? For example, I'm considering, so I want his roll number or serial number, I want his name, I want his age, date of birth, okay, and mobile number, phone number, and we can also add some address. So these are the right uh, various fields you whenever whatever you want to include in your uh, student database of a college. These are not mandatory. So, for example, I'm considering here, you can even take other than this. For example, student mail ID, student parent phone number, parent details, etc. Okay, MCET rank or previous degree ranks. So, all these things you can consider, right, based on your requirement. That is called requirement analysis. So, what things we need to consider based on the application. So based on the application, this requirement analysis will be completely changes. So please keep that in your mind. So if I prepare the employee database, for example, so employee having different things, right? So for example, employee name, right? Employee ID, okay, and any SSN, social security service number, right? And we can even take in India, we'll call it as Aadhaar number or PAN number. Okay, they are unique numbers. And we can also consider salary of the employee, we can consider date of join, we can consider experience, we can consider department, in which department he's going to join. It might be HR, production, sales, right, management, or administration. So these are the different departments, right? So this is a various fields or various columns or parameters which are needed to design the right database. So normally if I consider database, easy, simple, with example I'm telling, this is your simple database, right? And this I'm calling it as a relational database, because in the relational database your data is stored in the form of rows and columns. So these are the different rows and columns. You already see this, right? This is serial number column, this is name column, and this is age column, and I'm sorry, this is age column, and this is about salary column, and here address column. So example, right? So in this, so I'm taking serial number one, address, right? Address of this. So name of the employee is Bobby, okay, age is 32, salary is 1.2 L, and address is Hyderabad. Okay, so this is a one sample employee. I'm taking one more example, please. Name two, he's Mr. Missy, Miss Missy, and age is 45, salary is 4.3 L, address is San Francisco. Okay, so San Francisco, this is the address, right? So in this, each column we are calling it as the right, each column we are calling it as attribute. We'll call each column as attribute in your relational database. So from here on, we'll try to call each column as a attribute. Okay. So, and each entry, so each row or each entry will call it as a tuple, right? So from here on, we'll try to use these terminologies, right, to make our lecture to be very comfortable, right? So this is about, right, a database table, right, our relational database. So in the relational database, every information we are storing in the form of tables, right? And in the table, every column we are calling it as the attribute, and every row we are calling it as a tuple. Okay, right? So you have to take care of the requirement. Complete requirement analysis means what are the right what are the attributes we need to develop, what are the attributes we need to consider. Okay, and for every attribute we need to take care of some constraints, some constraint. So what constraint is, for example, right, if I prepare a employee database, if I'm preparing a employee database, I'm sorry, yeah, employee database, right? In the employee database, right, for example, there is a column called age, right? So just remember, right, in India, as per Indian penal code, so child labor is not allowed, right? So the constraint, whatever I'm giving to the age, is it should be greater than 18 years. Okay, and based on the employee designation or employee role, and it must be less than some 65 to 70 years, etc. Okay, so the constraint, age constraint here means it should be greater than 18 years and less than the some 65 to 70 years. This is the one constraint or condition, right, whatever I am giving for the age column. Okay, so that means whenever any employee database you want to insert in the database, so what happened is when you enter that employee serial number, it will accept, but right, when you are trying to enter age less than 17 18 years or above the mentioned threshold, then it won't accept. Okay, this is the constraint. And one more example, if you want to consider for a constraint, so I'm taking serial number, right? So this serial number preferably will try to maintain a unique serial numbers or unique SSN numbers, right? So to avoid the right duplications, so usually we won't allot these numbers, right, for multiple people. I mean to say, for different people, same numbers cannot be allotted. So that is a constraint for the serial number, right? So if you observe, Aadhaar number in India, it's unique. So no person having no multiple persons. So to no two persons having a single Aadhaar numbers, right? That was one of the constraint for the Aadhaar number. So similarly, the same manner, this is a requirement analysis about the right database table. And the second point is conceptual design, right? So I told you some constraints and all. These all comes under conceptual design. Mean to say that, right, what are the constraints you need to keep for every right column. So for example, if you take a phone number, so phone number in India, it has to be 10 digit mobile number, right? So if I enter more than 10 digit or more less than 10 digit, it shouldn't accept. Okay, that is a one more constraint. So these all thing constraints will to be considered in the case of conceptual design. Okay, and next, logical database. So whatever conceptual designs we have or conceptual thoughts we have, we'll keep them into a diagrammatical representation, also known as diagram. So these diagrams will take care of converting this conceptual implementation into a pictorial format, and this pictorial format will help us to design the database in a easiest way. We'll see what is diagram in the coming slides now, right? So this is about database design. And the fourth step we have is schema refinement. So after designing the diagrams, we'll go for the right actual implementation using various database designing languages, right? So after that, we'll take care of the any refinement is needed in the schema, right? So based on the tests. So if any refinements are needed, we'll go with it. So that was a schema refinement. And after that, we'll try to go with the real-time or physical implementation of the database and making application constraints and security complications to the design database. So these are the 6 basic steps we have in the database design. In the due course, we'll try to see up to schema refinement. In the schema refinement, we'll try to use various normalization techniques such as BCNF or normalization form 1, 2, 3, 4, etc. to avoid the redundancy and to avoid the right data repetitions. Okay, so that was the major things, right, in the design. So after the design, we'll try to see some right basics of introduction to the entity relationship diagram. They are also familiar with a name called ER diagrams. So very right useful to design a database. Okay, so we'll start with the what are the various right terminologies we have in the ER diagram. So before that, let me consider a table. I have already explained this now. This is a student relation table or student table which is having various attributes or also called as columns, and those are SID attribute, student name attribute, student login attribute, age, and GPA. These are the various attributes also called as column. Okay, and in this column, right, so in this column every one entry is called as a field. So remember, SID is a field, name also a field. Remember, Johns is also a field, Smith is also a field, 19 is also a field, right, 18 is also a field, and 2.0 is also a field. Every entry in the relational database is called as a field. And the row side, and I mean this side, horizontal side, so this 50,000 Dave, I'm sorry, just a second. Let me erase this first. Yeah. So in this 50,000 Dave at the rate CS, age 19 and 3.3. This total one particular entry, we used to call them as a tuple, or we also call them as a row or record. This is a record of Mr. Dave, or the record of SID 50,000. Okay, so this was the simple one table, a student table having various right fields or attributes, right? Chalo. So basic terminology which we are using in the entity relationship diagram is a very ER diagram is very first one is entity, or right. So entity. So this entity usually will represent with a rectangular box. So this is a rectangular box which we have here. So what is mean by a entity, right? So it is a object in the real time world, right? It may be physical or conceptual, physical object or conceptual object, right? What is it? We'll see in the class now. So for example, if I take a house, this is a entity. Physically house exists, right? We can see so many houses, right? Physical existence was there, right? Student or a person, this also physical exist. Course, right? Job, right? They are conceptual, or right, they are not physically exist, right? And then subject, these are the right physical or conceptual entities, right? We'll see in every day. Okay, and normally this entity will represent with a square box, so rectangular box, and which I have represented here. Okay, so for every entity having various attributes, I repeat, every entity will have some attributes, and these attributes help us to describe about the entity. I mean to say, student is an entity, but what is the age of the student, name of the student, what is a roll number, what is a mobile number, right? So these all are the basic information needed for the entity called student, right? So for this student, what are the information we needed? All those information, all those things will come, sir. We'll call them as an attribute, right? So this is a property that describes the entity. So for the student entity, I have told you so many attributes, right? So look at this diagram here. Student is a entity having various attributes such as birth date is one of the attributes, name is one more attribute, and roll number is the other attribute. So here name is an entity, student is an entity, and the name, birth date, roll number, all are the right attributes. Okay, and we have different types of attributes. We'll see them now, right? So among them, composite attribute and simple attribute. So composite attribute means a attribute can be divided further. So what it means, so if I take a student, right, name, so in the example, student name in the example, so name can be further classified into a first name, a last name, right? So this attribute name is divided further, right? So this is a right composite attribute example, right? If I take the roll number attribute in this, or date of birth attribute, these cannot be divided further. Yes, and these are the examples of simple attribute. right? So what is simple attribute? An attribute cannot be divided further into parts, right? Example, weight, age, salary, roll number, date of birth, etc, etc, etc. Okay, so these are the right composite attributes and simple attributes. And next we have single valued and multi-valued attribute. So if I take a phone number, so does a person have a single phone number or multiple? Sometimes multiple. So phone number is attribute having multi-valued, right? If I take a college degree of a student, right? If I take a student who is studying, who is pursuing his PhD or who is pursuing his masters, is also having a college degree called UG or I mean to say post metric, whatever. These are the different degrees what he pursued. Okay, and these are the example of multi-valued. Okay, so in this diagram, phone number is a multi-valued attribute, and normally this multi-valued attribute will show with a double oval or double eclipse, right? And normal entities will present with a single eclipse, right? And next, right, a single valued entity means having single value. Example, age. Age of a person is single, right? So it doesn't have multiple ages. Okay, so it doesn't mean that certificate birthday is different, usual birthday. It doesn't mean that. Okay, so next, derived attribute and stored attribute, right? So for example, take a employee attribute, sorry, employee entity, and this employee entity having, right, experience is the one of the right attribute. Remember this experience attribute, right? This experience attribute, right, depends on date of join. I mean to say, this employee experience will be depend on when he was joined in the particular organization, right? So this is depends on the date of join. So for example, date of join for 2024 means, right? So if 24 means 1 year, 25 means 10 days, 23 means 2 years. So means date of join automatically affecting the experience. So this experience is the right derived attribute from the right date of join. So this date of join here is called as a stored attribute, right? And this experience is the derived attribute. And remember, this derived attribute usually will represent with the right dotted oval. I'll show you here. This is the dotted oval. Will show in this format. Okay, stored attributes shown in the normal right ovals. Right. Next, we'll talk about complex attribute. So complex attribute is a combination of multi-valued attribute and composite attribute. Normally, while we are representing it on a paper or in a notes, right, we'll represent multi-valued attribute with this curly braces. Okay, so and composite attribute with the braces, normal braces. So complex attribute is a combination of both. If I consider a college degree attribute, right, it is having right multi-valued because multi-college degrees will be there, and each degree will have a multiple values. For example, degree means, for suppose a student pursued is BTech, okay, from ML or ITM, means BTech is a one attribute because course UG, because degree means you can pursue normal BSc degree or BCom degree or BTech or BE, whatever. This is one degree, one value or one attribute. And college name where you pursued your bachelor degree is also one more, year of passed out, and which branch or which department you studied or which section you studied. So BSc Max or BSc Computers, EC, EEE, Mechanical, Civil, CSE, whatever. So these are the different multi-valued for the one college degree, and these college degree can be multiple for a person, right? So this is a simple example of your complex degree, right? Complex attributes. And a very important one is null values, right? These null values are the missing values in a relation database or unknown values or not applicable values. They might be of unknown or not applicable because of basically two types. One is not applicable case, second one is unknown case. So I'll give a clear idea what is unknown. For example, right, let me take a Mahesh, right? Mahesh definitely, right, having some age. Okay, Mahesh having some age, 45 years, and mobile number. Remember, mobile number cannot be mandatory, right? Means, right, it is right. I'm sorry. Yeah. So in this, Mahesh is the name. For this particular name, age is a mandatory because every person having some age, that might be a 45, 25, 35, whatever. But the mobile number cannot be mandatory. Means, right, means I don't know whether the Mahesh is having phone number or not. Means here it is unknown. Here it is, right, here it is unknown. Okay, this is a case. Second one, if you see the Suresh case, so in the diagram, in the table, right, if you see the Suresh is there, definitely, right, his age is there, but I don't know what is the age. Means this age number here is missing. Age number is missing. So it can be a missing type. Okay, so here age is missing, but the mobile number in the case of Mahesh is not a missing case. It is comes under unknown case. Means we don't know whether he is having a mobile number or not, right? So it can be of not applicable case or unknown case. So this is of different examples, right? So this is the null attribute. Next we have, right, key attributes. So next terminology is key attribute. So if you observe this table, having three different columns, and each column having, right, different entities. For example, column number 1 is student ID having 1, 2, 3. Name attribute having Ramesh, Suresh, and Ramesh, and age is 20, 20 to 20. Now tell me, right, if I want to call a person with age 20, can I identify a single person or a unique person? I repeat, I want to call a person which having age 20, and that should be a uniquely. Mean no two persons should not come. So if I call with 20, Ramesh is also having 20, and other Ramesh is also having 20. Okay, that is one problem, right? If I even call with the Ramesh, so one Ramesh is here, one more Ramesh is here. Clear? So Ramesh cannot be, I cannot use the word called Ramesh because I cannot call them uniquely, right? If I use name as a key attribute means the attribute, right, that is capable of identifying each entity uniquely. Okay, name is not the capable entity to identify, right, each person uniquely, because if I call Ramesh, two people are there, and if I call even age, there are two people with the equal age. But look at the example, look at the third situation here. If I take SID or student ID as a key attribute, in this case, if I call with student ID, 1 is unique, 2 is unique, 3 is unique. So there is no repetitions at all. So in this table, to call them, so I prefer to use the student ID, so that, right, so that this confusion and misinformation will be overcome. Okay, so that was a key attribute. Next, value set of attributes, right? So what are the possible set of values assigned to a attribute? We'll call them as a value set of attributes. So for example, right, employee, right, age, employee age cannot be Suresh, because employee age must be an integer, and that might be in the range of from 18 or 20 to some 65. This is the value set. Okay, so that's a value set. Next one is entity type. So collection of different entities or attributes, same attributes, we'll call it as, right, entity type. So this table, right, having similar information about of a student ID and its name and its age and its phone number. So total is belongs to a student relation. So this is a student type entity. It's a student, right, related to entity related to student type. Okay. Next, set of or collection of various entities, which comes under entity set. We'll see completely in the due course, right? Next, weak entities. So, for example, if I take an entity called EMI, right? EMI. So you know what is EMI, right? So, can you guess, without loan, do you have EMI? No, right? So here, right, EMI or installment is a entity, and this entity of course depends on the loan. If there is no loan, no installment. and this installment entity depends on the loan entity. I repeat, installment entity depends on the loan entity. So that's why the loan entity, we are calling it as the right parent entity or owner entity. We are calling it as the owner entity, and this installment we are calling it as the weak entity. This is the weak entity and this is the owner entity. Okay, and remember, these two always connected with a small any relation, with any relation, right? And the relation between these two are called identifying relationship. We'll see the right in the coming slide. Okay, identifying relationship. So look at the example here, right? If I take the ATM, if there is no ATM, there is no transaction at all. So ATM is a owner entity, transaction is a weak entity. So these two weak entities normally will represent with the right a symbol called rhombus, double rhombus we are going to use here, right? So this is the relationship. So what is a relationship? Relationship, it's a right how two entities are connected, or I can say association between two entities, will call it as the relationship. So normally will represent in the rhombus for relationship, right? It is preferably useful to connect the two different entities. Okay, so this is about right an ER diagram basics. So see a sample ER models for the college administration. The student is an entity. Okay, exam is an entity, record card is an entity, or report card is an entity. Okay, and student having name, it's a composite attribute. First name, last name, they are the simple attributes. Student ID, so that underline indicates it's a key attribute. This is the key attribute. Phone number, date of birth, these two are the simple attributes. Again, address is the composite attribute. Okay, can be divided further into house number and city and street, etc., etc. And exam is a one more entity having exam number, student's subject number, a subject name, and the student IDs which are who are writing the exams, right? So these two entities are connected. I repeat, these two entities are connected using a relationship, and that relationship is this one of any type. Okay, this is a simple example of ER diagram. So rest will continue in the tomorrow session. There are other sample examples we have. We'll discuss them as a homework, and in the next session we'll try to discuss about right in detail about relationships and their cardinality ratios. Okay, thank you.